Metabolic functions of the liver. The liver is a large chemically reactant pool of cells that have a high rate of metabolism, sharing substrates and energy from one metabolic system to another, processing and synthesizing multiple substances that are transported to other areas of the body and performing myriads of other metabolic functions. But here, let us summarize those metabolic functions that are especially important in understanding the integrated physiology of the body. First, the carbohydrate metabolism. In carbohydrate metabolism, the liver performs the following functions: 1. Storage of large amounts of glycogen; 2. Conversion of the galactose and fructose to glucose; 3. Gluconeogenesis; 4. Formation of many chemical compounds from the intermediate products of the carbohydrate metabolism. C. The liver is especially important for maintaining a normal blood glucose concentration. How? The storage of glycogen allows the liver to remove excess glucose from the blood, store it, and then return it to the blood when the blood glucose concentration begins to fall too low. This is called glucose buffer function of the liver. What is now? Let's talk about the fat metabolism. Although most cells of the body metabolize fat, certain aspects of the fat metabolism occur mainly in the liver. 1. Oxidation of the fatty acids to supply energy for other body functions. 2. Synthesis of large quantities of cholesterol, phospholipids, and most lipoproteins. 3. Synthesis of fat from proteins and carbohydrates. To derive energy from neutral fats, the fat is first split into glycerol and fatty acids. Then fatty acids by then fatty acids are split by beta oxidation. Uh, Initially, uh, fats into glycerol and fatty acids. Then fatty acids is split into two carbon acetyl radicals by beta oxidation to form acetyl coenzyme A, that is acetyl CoA. This can enter the citric acid cycle and be oxidized to liberate tremendous amounts of energy. Beta oxidation can take place in all cells of the body, but it occurs especially rapidly in the hepatic cells. Now let's talk about the protein metabolism. The body cannot dispense with the liver's contribution to protein metabolism for more than a few days without death ensuing. The most important functions of the liver in protein metabolism are the following: 1. Deamination of the amino acids, which results in the formation of the ammonia. For this, the ammonia is eliminated from the body via the urea. The second function is the formation of urea for the removal of the ammonia from the body fluids. Now, 3 is formation of plasma proteins. 4. Interconversions of various amino acids and synthesis of other compounds from amino acids. Now, let's have a discussion over other metabolic functions of the liver. That is, the first function is the liver is a storage site for vitamins. How? The liver has a particular propensity for storing vitamins and has been known as an excellent source of certain and has been known as a excellent source of certain vitamins in the treatment of patients. The vitamin stored in greatest quantity in the liver is vitamin A, but large quantities of vitamin D and vitamin B12 are normally stored as well. Now, another function is the liver stores iron as ferritin, except for the iron in the hemoglobin of the blood. By far, the greatest proportion of iron in the body is stored in the liver in the form of ferritin. Thus, the ferritin system of the liver acts as a blood iron buffer as well as iron storage medium. Thus, the ferritin system of the liver acts as the blood iron buffer, blood iron buffer as well as an iron storage medium. The liver forms the blood substances used in the coagulation. The substances formed in the liver that are used in the coagulation process including the include fibrinogen, prothrombin, accelerator, globulin, factor 7, and several other important factors. Vitamin K is required by the metabolic processes of the liver for the formation of several of the substances, especially prothrombin and factors 7, 9, and 10. In the absence of vitamin K, the concentrations of all these decrease markedly, and this almost prevents blood coagulation. Right? The liver removes or excretes drugs, hormones, and other substances. The active chemical medium of the liver is well known for its ability to detoxify or excrete into the bile many drugs, including sulfonamides, penicillin, ampicillin, erythromycin. Similarly, the several of the hormones secreted by the endocrine glands are either chemically altered or excreted by the liver, including the thyroxine and essentially all the steroid hormones such as estrogen, cortisol, and aldosterone. Right? Liver damage can lead to excess accumulation of one or more of these hormones in the body fluids and therefore causes overactivity of the hormonal systems. Finally, one of the major routes for excreting calcium from the body is secretion by the liver into the bile, which then passes into the gut and is lost in the feces. One of the major routes for excreting calcium is a calcium from the body is secretion by the liver into the bile, which then passes into the gut and is lost into the feces. Right?